Okay, so we're going to practice some problems with domain and range. You could have the equation y equals x plus 3, or you could write that as f of x equals x plus 3. You could have a map of values. You could have people. You could have Bob and Sue and Kathy. And maybe the function is what class are they in. Maybe Bob is a junior, and maybe Sue is also a junior, and maybe Kathy is a senior. The function could also be represented as a set of ordered pairs. So you could have the set of points 5, 1. It could be 2, 7. Maybe it's also negative 2, 7. So these are three different ways to represent these three different functions. If we look at the domain and range of these functions, the first one was the equation y equals x plus 3. Because we can plug anything we want into for x, then the domain is all real numbers. Or we would say the domain would be from negative infinity to positive infinity. The range would also give us any possible number because it's a straight line, so we could get any value we wanted for the range. So the range would also be negative infinity to infinity. On our second example, the domain would be the people, Bob, Sue, and Kathy. So the domain would be the set of those people. The range would be your answers. So in this case, it was just junior and senior. If you talked about the whole high school, your range would be freshman to senior. On the third example, we would take the x values for our domain. So they would be the set of the numbers 5, 2, and negative 2. The range is all the possible answers we had, and that was just 1 and 7. The domain on this graph goes from negative infinity to positive infinity. You can tell that by looking at the graph. I have a value for the function for all x values. You can also tell by looking at the equation. I can plug anything I want in for x, and I can square it and take 5 minus that number. The range, however, never gets bigger than 5. Range is like bottom to top. So the bottom values are negative infinity. But it's never going to get bigger than 5. It is, however, going to be equal to 5. So I'm going to put a bracket here showing that it can equal 5. You can tell this by also looking at the equation. No matter what I plug in here for x squared, I'm going to get a positive number. So the smallest this can be is 0. So 5 minus 0 is still going to give me 5. This equation also has a domain of negative infinity to infinity. You can tell that by looking at the graph. You can also tell that by looking at the equation. I can plug anything I want to in here for x and subtract 3 from it, and then take the absolute value of that and then subtract 2. So again, my domain is all real numbers. My range, though, is going to start at negative 2. And it's going to get bigger. So I'm going to go from negative 2 to infinity. Never going to get a number smaller than negative 2. You can tell that by looking at the graph. Now, it does equal negative 2. So I'm going to put a bracket here around negative 2, showing that my range starts at negative 2. It includes negative 2. The domain on this graph is a little bit different. It starts at negative 4 and goes on to infinity. It can actually be equal to negative 4, though. I can plug negative 4 in for x over here and get 0 and take the square root of 0. So because it can equal negative 4, I'm going to put a bracket around it. So that's my domain, negative 4 to infinity. And you can see that on the graph. Here's where my x values are. They start at negative 4 and go on forever. The range is like bottom to top. So it starts here at negative 6 and goes on to infinity. Again, it can be equal to negative 6, so I'm going to put a bracket around it.